In this lesson, we are going to learn how to solve logarithmic equations. This can be found in section 10.7 of your book on page 859. So we are going to learn how to solve logarithmic equations. And if there is no base written for a logarithm, it is understood to be 10. All right. And finally, your answer will work as long as the input isn't negative. We'll talk a little bit about that in just a second. So we've got log base 3 of x equals -2. So the first thing we need to do is translate this from logarithmic form into exponential form. So exponential form, you would write your base, and then these two are essentially going to switch places. So this -2 is going to become the exponent of my base, and then it's going to be equal to x. So now we just have to figure out what this is so we know what x is equal to. So to move this, we're going to want to get our exponent positive, so we move it to the bottom of our fraction. So that becomes 1/3 squared equals x. And then to finish this off, we would say 3 squared is 9. So our final answer is 1/9 equals x. If you're not quite sure what kind of sorcery I just did right here, then you may want to look back at my video on integer exponents. It was section 5.2. All right, so now number 4, we're going to again put this in our exponential form. So we write our 5. And then this 3x minus 2 and 3 are going to switch places. So this 3 is going to become the exponent of my base. And then we have our 3x plus 2. So now we solve. First thing we do is take care of this exponent over here to make it a 125. And we get that by doing 5 times 5 times 5. Bring everything else down. Now we have to get x by itself. So move your 2, so you subtract 2 on both sides to get 123 equals 3x. And then to get x by itself, we're going to divide both sides by 3. 3 goes into 123 41 times, so 41 equals x. So we said your answer will work as long as the input is not negative. So what that means is when we plug this answer of 1/9 into our x right here, as long as this is a positive number, we're good to go. So if you plug a positive 1/9 into that x, then it's still going to be a positive. And if we plug 41 into this x, 41 times 3 is going to give me 123, plus 2 is 125. It's still a positive number, so that one's good. So here, notice that you've got 2 logarithms written down. So the very first thing you need to do is rewrite this as a single log. So we have log of 5x equals 2, because when you're adding here, you're actually multiplying those bases. And we said that this base right here, if there is no base written, the log is understood to be a 10. So we're going to put a little 10 right here. So now we're going to translate that into our exponential form. So we write our base first, exponent of 2, and then we have it to equal to 5x. We're just switching these two right here. Then we're going to find out what 10 squared is. So that would give us 100 equals 5x. And then to get our x by itself, we're going to divide both sides by 5 to get x equals 20. If we were to plug 20 into our x here, it would still be a positive number. So we're good to go. So on number 8, we're going to rewrite it as a single log. So we have log of x divided by 8, because when you subtract your exponents, you're really dividing those bases. So x divided by 8 equals 3. And I forgot to write my base of 4 there. So now we're going to rewrite this in exponential form. So rewrite your 4 to the third power equals x over 8. So now we need to find out what 4 to the third power is. And that would give us 64. And then to get our x by itself, we're going to multiply both sides by 8, because the opposite of dividing x by 8 would be to multiply. So we end up getting 8 times 64. 8 times 4 is 32, carry your 3 over. 8 times 6 is 48, plus 3 is 51. So your answer is 512. So if we were to plug 512 in there, it would still be a positive number, so we're good to go. On number 10, we're going to write it as a single logarithm. So we have log base 3 of x times 2x plus 3 equals 2. Since you're adding here, we're going to multiply the x and the 2x plus 3. Then we take our base to the second power equals x times 2x plus 3. And we're just writing it in that exponential form. Now we say 3 squared is 9 equals 2x squared plus 3x. And then whenever we have that x squared there, that's a quadratic equation. That makes this a quadratic equation. So we're going to want to set this equation equal to 0, which means we're going to want to move that 9 over here to this other side. And then we're going to want to solve. And we've got a couple different ways of solving. In this class, we've talked about solving by factoring and solving by the quadratic formula. So it really just depends on which method is your favorite to work with. For me, it's going to be the factoring method. So I do this by drawing this x. My a and my variable I'm using go on top. A times c goes up here, and my b goes down here. And we find what multiplies to give us negative 18 and adds to give us 3. So that would be 6 and 3, and the 3 would be negative. And before I write this out in factored form, I have to simplify this 2 over 6 to make it a 1 over 3. So I now have 0 equals x plus 3 times 2x minus 3. And the reason I didn't simplify this, guys, is because it was already simplified. You can't simplify a 2 over 3. And then you set each of these equal to 0 and solve. So minus 3 on both sides, and then plus 3, and then divide by 2. And so now we take each of those answers. I'm not sure if y'all can see that handwriting's a little small. So we've got answers of negative 3 and positive 3 over 2. So when we plug these in here, if I were to plug a negative 3 in here, that would give me a negative input. So that means that's not a good answer. I can't use it. But if I plug 3 over 2 in for this x, it's a positive. If I plug 3 over 2 into this x, then that would end up giving me 3 plus 3, which is 6, which is positive. Okay, so 3 over 2 is the only answer we have there. All right, so now to move on to number 12, write it as a single logarithm. So I have log base 2 of x plus 2 times x minus 5 equals 3. Then write it in that exponential form to get 2 to the third power equals x plus 2 times x minus 5. And then we're going to say 2 to the third power is 8, and I'm going to distribute right here. So x times x is x squared. X times negative 5 is negative 5x. 2 times x is 2x. 2 times negative 5 is negative 10. Now we're going to combine those like terms to get 8 equals x squared minus 3x minus 10. And then remember, when we have a quadratic equation, we want to set it equal to 0. So we do that by moving this 8 to this side. So we have 0 equals x squared minus 3x minus 18. And now you can solve it by factoring, quadratic formula, any method that you choose. So we end up getting x minus 6, x plus 3, because those two numbers multiply to give you negative 18 and add to give you a negative 3. And then set each of those equal to 0. So x minus 6 equals 0, x plus 3 equals 0. Add 6 to both sides, minus 3 on both sides, and you get answers of 6 and negative 3. Now when we plug these in, we've got to make sure that they give us a positive input. So take your 6 and plug it in here to this x. 6 plus 2 is 8, which is positive. 6 minus 5 is 1, which is positive. So 6 is a good answer. Negative 3. Well, if I plug negative 3 in for this first one, negative 3 plus 2, well, that would give me a negative 1, so it wouldn't work. So negative 3 is not a good answer, and so our answer is just 6. All right, so now let's flip over to the back page. And so we're going to write this as a single logarithm, and since this is subtraction here, we're going to divide. So I've got log base 5 of x plus 5 divided by x equals 2. And then I'm going to put it in my exponential form. So 5 squared equals x plus 5 over x. 5 squared is 25. And we need to get rid of this x down here in the denominator. So the way we do that is we multiply it by x on both sides. And when we do that, those guys there cancel. And we're left with 25x equals x plus 5. And so if you're not quite sure about the rules on solving equations, step 1 says to remove your parentheses. Step 2 is to combine like terms on each side of the equal sign. Step 3 says to move all x's to one side. And I've got a little hint here. Always move the smaller x because that's going to keep your x's positive. So always move the smaller one. And then step 4 is going to be to simply solve. So here, if we've got x's on both sides of my equal sign, then I want to move one of them. And it tells us to move the smaller x. So between 25 and 1, we're going to move the 1. So minus x on both sides. If you need to write that 1 there to see it, then that's perfectly fine. You end up with 24x equals 5, because those cancel. And then divide both sides by 24. You end up with x equals 5 over 24. Okay? So now, same thing here. Write it as a single log. So log of x plus 2 over 2x minus 1 equals 1. And notice there's no base written. And we remember that that base is understood to be a 10. So now, exponential form says I have 10 to the first power equals x plus 2 over 2x minus 1. And to get that 2x minus 1 out of the denominator, I'm supposed to multiply it. So 2x minus 1's cancel. And I'm going to multiply that 10 by 2x minus 1. And then rewrite my x plus 2. So I'm going to distribute here to get 20x minus 10 equals x plus 2. Subtract x on both sides to get 19x minus 10 equals 2. The reason I moved that one is because it was the smaller of the two. Add 10 on both sides to get 19x equals 12. And then divide both sides by 19 to get x equals 12 over 19. So again, make sure that you keep checking your input and make sure that they keep giving you correct answers. So if we were to plug these in, then they would still work. All right, so number 18 is a little bit different because you notice that there's logs over here and over here. We've never seen one before that has a logarithm over here. So let's first go ahead and combine this the way we know how to do. So we have log base 3 of x plus 12 over x minus 3 equals log base 3 of 6. Okay, so when we have a log with the same base on each side, then that means that we can take our expressions here and set them equal to each other. So if these two are the exact same base and everything, then we can do that our x plus 12 over x plus 3 equals 6 and solve from there. So we multiply x plus 3 on both sides. Sorry about that, that says x plus 3. And those two cancel to give us x plus 12 equals 6 times x plus 3. So I'm going to distribute here. X plus 12 equals 6x plus 18. Now I move all my x's to one side. Between 1 and 6, 1 is the smaller, so we move that one. And have 12 equals 5x plus 18. Minus 18 on both sides because our goal is to get that guy by himself. And 12 minus 18 is negative 6. All right. Oh, I just realized, guys, that we had a minus sign here. So I copied it down wrong. I'm so sorry. So let's actually skip all the way back. I am so sorry, y'all. Y'all were probably really confused. Give me just a minute. It changes the whole problem when you write just one little thing wrong. So notice there was an x minus 3 here. If you noticed, I wrote an x plus 3 on accident. Okay, so now let's try this again. Multiply this by an x minus 3 and this by an x minus 3. So that gives me x minus 3's cancel, so x plus 12 equals, distribute that out to get 6x minus 18. Now, minus x on both sides because it's smaller. So we have 12 equals 5x minus 18. And then add 18 to both sides to get 30 equals 5x. And then divide both sides by 5 to get 6 equals x. When we plug that into our input, it does still give us a positive answer, so we're good. And so now for the final problem, I have log of x squared plus 1 over x minus 2 equals 1. My base is an understood 10. So I have 10 to the first power equals x squared plus 1 over x minus 2. So to change that x minus 2, to get rid of it, I'm going to multiply everything by x minus 2. So I now have 10 times x minus 2 equals x squared plus 1. Distribute here to get 10x minus 20 equals x squared plus 1. All right, and now remember, since we have a quadratic equation, since this is squared, I'm going to go ahead and move everything over to this side. So we have 0 equals x squared minus 10x plus 21. And all I did was just combine these like terms here. So we have x minus 3, x minus 7, and we get answers of a positive 3 and a positive 7. So when we plug each of those into our inputs, we notice that both of them give us positives, so both of those are good answers. So I hope that this video has helped you, and I wish you the very best of luck. Have a good one.